Hello everyone. This video is for a graded assignment for managing machine learning projects from Coursera module number 5. So this graded assignment is for me to think through how I would design a machine learning application right from its inception to the deployment and the maintenance of the same. So the subject area I've taken is the IT operations. Basically, every business have a IT operations as a department which manages the whole infrastructure. Sometimes also have people in there that monitors and maintains applications that are built in the firm. It is it is an ever engaged teams within the department that continuously monitor and maintain the applications so such that there is very less downtime and every application is kept up and running so as to keep the customers engaged in the business. It's a cost. It's an expensive team to run in an organization. So we'll see how a machine learning application uh, can help or cannot help. So we'll look at the following aspects. This is how I will start. I will look at an opportunity evaluation to see if there is an opportunity for a machine learning model that could help. And we'll also leverage this CRISP DM framework to understand the business. The CRISP DM framework establishes a, a life cycle. It's not linear. It's cyclic in nature. You can actually start from point A, point B, point C, and then go back to point A and you can continue to improve on. So we're gonna start off with CRISP. We'll use the CRISP DM framework. We'll start understanding the business and see what goal we could define for this model and see if the machine learning model would even in fact be an optimal fit for this. So let's say we choose to do a modeling approach, then we'll come up with a plan to see how a model can be validated for its fitment into production. We'll look at the system design of the same, and once it makes it into production, we'll see what would be the potential risks, and finally we'll conclude. Opportunity evaluation. So I would start off understanding the current monitoring and management of IT operations in a business. The monitoring aspects would vary, right from the people that monitor databases will differ from how the network engineers would monitor the network to the server engineers, and it all would differ, and how it is being tracked, how it is being logged, how is it is being prioritized, everything would be different, and how things are seen in relevance. For example, a database infrastructure team reporting an incident saying a database is being down would ultimately impact many of the applications in the firm. The application teams may not realize, but it's an upcoming event. So I'll try to identify what the pain points are in the IT operation as a whole, and see what we can improve. And we'll see if a ML model can help solve or improve the situation here, right? I would definitely think a machine learning application can predict a potential failure or performance in the infrastructure, such as servers, databases, network components, using variety of different situational data. It can analyze logs, metrics, performance data, the time of the year, the day, uh, to to kind of detect early if there would be an issue upcoming or brewing, or and can recommend a preventive solution. So we'll go with a machine learning model. Given that we have all this data available, the model can at least try and predict which can be used by teams to respond very quickly. So here is a picture about the CRISP DM framework. It starts off with business understanding. There should be a clear documentation of what the business does, how the model can help, and what would be the outcome if we ever do this model and then release it into production. So we'll understand the data, what sort of data is available, what sort of data is needed for the model, and if the data is clear and there is no anomaly, how can we curate the data for the use in the model? Then the model itself, how do you do it? And then how would you evaluate for its performance. And once you deploy it, you would take a customer feedback. In our sense, this is a not really a customer prediction, but it is to for us to improve the IT operations. So we're gonna use different thresholds to see, are we performing better? Did we really predict early a problem? So on and so forth. So this is a cyclic in nature. It's continuous evolving process. So which will upkeep our model. Business understanding. So I think the goal, the objective is to minimize the IT infrastructure downtime, optimize the performance by predicting failures, bottlenecks before they can occur. Optimize performance in the sense that if you had allocated too much of a resource to one part of the application but it is underutilized, you could have predicament saying, this part of the resourcing can be moved to another application which poses high in demand. So this will enhance service reliability and reduce maintenance costs. This is going to be the model objective. Who are the stakeholders? The stakeholders are IT operation teams, system administrators, business continuity managers, and financial officers. What would be the outcome if the model is deployed? The outcome, business outcome, would be improved system uptime, reduced incident response time, and cost savings from avoiding unexpected failures and performance issues. I would like to add a point here. Things like www.bankofamerica.com being down, there could be a legal or reputational or even financial risk associated by someone suing it, that they could not do a critical wire transfer, for example. So for the business, it is the and now on avoiding an unexpected failure means a lot. So data understanding, what kind of data we have, what are the data sources we have. We need system logs from every single application, monitoring tools that we currently use, like CPU usage, memory utilization across all different servers, and where different applications are being deployed and is running off of. Historical failure, time of the failure, date of the failure, and surrounding context information around that. And then incidents. Incidents are something that is being reported when it is highly in severity, impacting, let's say, 10,000 customers, for example. So all sorts of curated data is what I would look for, collect all them. And description data, data, I put in a data description here saying, it's going to be a time series data, so point in time what happened. Logs, metadata about the infrastructure, for example, if a server often goes down, you could know what the operating system is, what kind of CPU architecture it is on, RAM available, disk space available, which network scheme it's on, and things like that. So data quality assessments, we certainly need to assess evaluate the completeness, accuracy, and consistency of the data. If there are gaps, if there are anomalies, we got to have tools that will show us what the anomalies, where the anomalies are, and we need to apply some predictive model to anomalies. We should iron out the anomalies either by averaging or completely skipping. It is for the nature of the data that you would choose certain things to close up these gaps. So now let's say we ought to develop a model. We'll have the data set, all the source data with incident data. Incidents are where the servers or databases that went down impacting customers. So we have all this with the time of the incident that has happened. So what we would do is we'll divide the data into training, validation, test sets to build and evaluate the final model performance on the unseen data. We would have done this in the previous course. I'm just reiterating it here. To validate, we'll use the k-fold cross-validation with the historical data to assess the model's predictive accuracy. What could be our metrics that could assess the performance of the model? We might use precision recall, mean time to detect. How early was it able to detect? Mean time between the failures to validate the model. So that's the kind of metrics that I would think of using in this scenario. So design decisions, model choice. So we can use time series forecasting models or anomaly detection algorithms such as isolation forest to predict potential failures. It is something in combination that might result in something going down. So the algorithm There could be many. These are the things that come up to me as a model choice. So deploying the system into cloud for scalability and real-time monitoring. The most of the organizations today deploy over cloud. So cloud deployment can also facilitate integration with various data sources across organizations. Training. We'll use offline training with regular updates to incorporate new data and improve model accuracy over time. So it's a continuous learning. It's an offline training. We would also set different thresholds um, such so as to keep monitoring the model performance. So if it ever goes below, then it means we need to relook at the model to understand if there is any drift in the data or the concepts. Now, model is deployed. What could be the potential issues? As I said just before, it could be a data drift. So we will monitor for changes in infrastructure usage patterns that could affect model performance, and we would have to implement retraining strategies to address the data drift. The false positives, negatives, we would have to balance the model to minimize the false alarms that could lead to unnecessary interventions while ensuring critical issues are not missed. System integration. Ensure we need to ensure the system that we develop as a whole can integrate seamlessly with existing monitoring and alerting tools to provide actionable insights to IT teams. We can predict unless it makes up to someone's computer or someone's attention, it cannot be avoided. So that is where the system integration is the most important thing so that it can integrate very seamlessly. So of all this exercise, what is the outcome? CRISP, my learning is CRISP TM as a framework in abstract sense provides a continuous evaluation process. It's a complete uh, kind of a model lifecycle framework from evaluating, building, deploying, and maintaining a model, a machine learning solution. This process is continuous, which means you are heavily invested. It's like you can't have people build and move on to the next projects. It has to be continuously monitored and maintained, so the model can be upkept. This will significantly so following all this will still significantly improve and reduce the cost for IT operations. Thanks for watching this video.